Hello, I'm Pete Starkey at Real Time with IPC. Delighted to have the opportunity to sit and talk with Phil Kinner, who is Technical Director of Coatings Division with Electrolube. Phil, great to see you and thanks for sparing the time to join us.
Always a pleasure, Pete.
Thank you. Phil, we know Electrolube as a global company, and I say in your division you have a whole family of research groups developing products for the requirements of their local markets, but also cooperating globally in developing products for the world market. Could you just tell us a little bit more about that?
Sure. That's a very good point, and that's really one of the key things about being a global business is that ability to develop products for specific applications in the local markets. Yeah. But then taking a step back and looking at the common features of those products and what we can take and use on a global basis. Yeah. And I guess a good example of that would be the recent range of UV materials that we've launched here at Apex. Yeah. Some of them are developed in China, some of them are developed in the UK. Yeah. But that's really the kind of the key output of that global reach. Yeah. And the challenge, I guess, is twofold. So, firstly, there's some existing issues with technology. Yeah. So in China, for example, it's become very difficult to use traditional flammable solvent-based materials, and so the customers have had to transition to UV materials very quickly. Yeah. And that has created quite a need for rapid response, rapid development of technologies for those applications. Yeah. Well,
I've had a lot of past experience of covering flat surfaces with single pack UV cured materials. Okay. But I think when you're applying a conformal coating to a printed circuit assembly that's got all sorts of third dimensional features, that must present you with certain problems in making sure the UV gets to all the places the UV needs to get to.
Well, that's a very good point. The light travels in straight lines, so it's difficult to avoid shadowing with UV curing, and so inevitably you need a secondary cure mechanism to make sure that if you don't see the full dose of UV, you still have the material curing.
So how does that work traditionally?
Traditionally, it's based on a moisture initiated reaction. The issues with that really is if the coating's a good barrier to moisture, which you kind of hope it is, because that's one of its prime functions.
It's going to be a slow job.
Yeah, then it's going to be a slow job. It's going to take a long time for that moisture to get in.
Yeah. And then typically how long, Phil?
Can be days, can be weeks,
really?
Months.
Yeah.
Can be never. So that's kind of a known limitation. Talking about the topography as well, the other issue is traditionally the materials have been quite prone to cracking during thermal stress. Yeah. I guess our two key developments moving forwards are developing a chemical cure mechanism that ensures that we get full cure within 6 hours, which is kind of a huge improvement on never. Yeah, yeah. Or it depends, because engineers love. Well, it depends. Yeah. And then the second aspect of that is getting good coverage over those component leads is really important to the level of protection you can get.
Yeah. What are your typical application methods?
It's nearly always selective spray. Yeah. Or some kind of selective dispensing process. But getting that coverage, getting that thickness is traditionally a real challenge. Yeah.
You mentioned thickness. Give me a sort of baseline in thickness.
Typically, these materials will be used 100 microns on a flat surface. Yeah. If you're getting 1 or 2 microns on the edge of a component lead, then that's probably a good result traditionally. Yeah. So kind of what we're trying to do is try and make sure we get that 100 microns kind of uniformly around the component. Yeah. to make sure we get the best
So
level of protection that we can.
Viscosity and rheology are sort of important parameters within the formulation.
Exactly.
Yeah.
And then with the rapid secondary cure,
Yeah.
and then building in the ability to withstand those thermal cycles, the thermal shock,
Yeah.
to achieve what the customers are looking for, then that's kind of the key thing that we solved with this range of materials.
What kicks off the secondary core then? Why doesn't it go off in the pot?
The particular solution relies on mixing two materials together just before.
Oh, I see. Yeah.
Just before point of application.
Yeah.
So once they're mixed.
I understand.
Then the
I got it in my head that we were still talking about single component material. No. So it's basically a two pack material, and you're mixing it at sort of point of contact, point of application. Yeah.
And therefore, once they're mixed, you're guaranteed to get the curing process.
Yeah. No, that clarifies it for this Densol bloke. Yeah.
Okay.
So, where from here? Have you actually launched this range at the show?
Yes.
Yeah.
So this is the first time that we've pulled together the entire range. So whatever the application the customer has, we have a solution that's going to fit their requirements.
Sounds great. No, I'll be very interested to wander down to your booth later and take a look. And now we're at the booth of Electrolube. I'm still with Phil Kinner, but Phil has some actual samples that we can discuss. Phil, could you please give me some sort of description of the bits that you're holding in your hand?
Sure, Pete. So we're talking now about the chemical cure materials that we were talking about.
Yeah.
So this is a transparent material, UVCLP, that's designed to be applied at normal coating thicknesses but still give better coverage without being very different from a material that a customer would look at every day and kind of recognize. Here we've moved to a product called UVCLX. UVCLX is designed to give the highest level of protection.
Yeah.
So now we're moving from like 100 microns we were at before to about 250, 300 microns. That thickness necessitates flame retardants to meet the UL 94V0 requirements, which creates an unusual looking color in the coating. So we've deliberately made it green in this case because that's the customer's corporate logo. But in the words of Henry Ford, you could have it in any color apart from black. I guess I'm paraphrasing. So what we can see, the leads of the IC really well coated, tops and sides of the capacitors are on there.
Thanks for your time, Phil. It's been great.
Thanks, Pete.
Pleasure. Pete Starkey, real time with IPC. Thank you.